All right, class, so this is the answer key for our energy test. So first of all, of course, there is that page to make sure you sign, claiming that you're doing all of your own work. There are a couple of things that we talked about in class regarding that, but right now we're here to talk about the answers to this. So as I looked at the first question, the first way I solve this is I want to know where the zeros are, and the question asks very specifically for that. So it's a little reminder that although the test doesn't show it too well, we can see the zeros here and here, which is indicate every time the cart is at rest. So that was 3 and 10 seconds. Okay, so a lot of people drew that in, that's fine. You'll notice that's not a scored question, but if you don't know where the zero is, that's going to cause a problem. People also noted I had this out of whack here. This was supposed to be velocity, and this was supposed to be time. Okay, that's, I don't know how that happened, but that was purely my mistake there. So that was the first thing we needed to correct there, and that gave us our first points. Next up, indicate every time interval for which the speed, which is the magnitude of the velocity of the cart, is increasing. So that means going away from zero. Okay, so once again, if we're looking at this, it is all of this section and all of this section. Okay, so that is for t from 3 to 6 and t from 10 to 12 seconds. Okay, a lot of you wanted to say 2 to 6 was an increase in speed. It's an increase in velocity, but it's not an increase in speed. Okay, determining the acceleration of the cart at time of t equals 10 seconds, location is x equals -5 and t equals 0. That was just thrown in there to see if you're paying attention. We don't care about that. Determine the acceleration of the cart at t equals 10 seconds. Okay, if we're going from velocity to acceleration, we want slope. Okay, you can have any portion of this line here. I'm going to take the whole thing to make sure I don't miss anything. So it starts at 6. Well, let's back to back and do that. I'm going to go from 6 to 0 is going to be my rise. It went, okay, and then my run was from 6 seconds to 10 seconds. Okay, so now we have our acceleration. Now this is where the one gets tricky, and this is where this becomes important. So at t equals 0, x equals -5. So they're telling us the starting point here. Okay, now what I want to do is plot a few key points here and then think about what kind of line I'm going to draw here. So I want to figure out what's happening here. Maybe you want to think about what's happening here, but we definitely want to know what's happening here and over here. Okay, so in that first section, okay, if we're looking at this, I throw my marker on the ground. Okay, if we're looking at this for this first section here, okay, distance is the area under the curve, but under is a kind of a terrible word because we're in the negative, so it's between 0 and the -2. So what we see is that this area, 2 by 2 box, okay, means it goes down another 4. Okay, so by here we've gone down another 4. Okay, and then this area is a 2 by 1 triangle. So right, this was -2 by 2. This one right here is 1/2 of base times height. which is 1/2 of 1 times -2, okay, which is a long way of saying another -1. This one was -4, so we went down 4, and then we went down 1 more. That's 5. Okay, now we are finally in the positive velocity. We are going to start moving forward now. Before we were moving back, now we're going to move forward. So now we can think about this area here. So that was 1, 2, 3 seconds here. And what do we have here? 1, 2, 3, 4, 5, 6. Okay. 6 there. So again, we're going to do our 1/2 base times height. 1/2 of 3 times 6, which sounds like 9 to me. So I was down at -10. At this point, at 6 seconds, I'm going to go up 9. Okay. And then let's do a couple more points here. Next point, we're looking at the area under this curve. Well, we're still at a height of 6, but now we're at a base of 4. So if we're doing 1/2 of base times height, it's going to be 1/2 of 4 times 6, okay, which sounds like 12. So I was at -1. Now I'm going to go up 12, and that is where I'm going to be at 10 seconds. Okay, and then what happens here? Now I'm going to start going back down again. So this is a 2 by 2, 1/2 base times height. It's 1/2 of 2 times -2. Okay, so that is going to be, sounds a lot like, I'm going to go down 2 here. Okay, so by 12 seconds, I'm going to finish up something like this. Okay, so now I have my points. Some people are going to see comments that the points were good, but the shape was not. Some people's comments, shape was good, points were not. Okay, so this right here, we have not changed our slope or our position. Okay, so if we are staying at a constant velocity, that means the slope of this line should be fairly constant. Okay, here we keep changing our velocity, which means the slope of this line is going to keep changing. So it is going to curve, okay, going from a more negative to a 0 curve here. So it's going to look something more like this. Okay. Then we go, our velocity goes faster and faster. Okay. So now we're going to come up. And then finally, we're going to curve off. Okay. So that's what our curve should look like. So some of you will see a comment, it should look more, a little bit more like a sine wave there. Okay. So that is what we expect to see for our distance time graph.